Okay, let's continue to derive, okay, applying power rule. And we have the power rule, and we're going to bring it down with us. But I think by this time, you probably haven't remembered the formula already. So let's start it with a simple example. This one, f of t, okay, equals 2t to the power 3 minus 3t squared minus 4t. You can see the variable is no longer x. Okay, so we have to, adjust our understanding about the variable because the variable they just a placeholder after all. Okay, so now if we differentiate, and because the function of t, so we're going to write it as f prime of t. And we can also use the other notation, which is derivative of dt of f of t. These two notations they mean the same thing. However, the second notation can better explains, as we said, right? By definition of derivative, it indicates it's with respect to t. So in our situation, this is a derivative with respect to t. Okay, so let me move up a little bit. So x will be changed to t. X will be changed to t, right? So we often see these changes. Depends on the situation. So if this is the word t, and this is t, and this is t, right? So you can just change to any variable you want. But one thing is certain, we can change the different variables, but there are three places that must be consistent. Three places must be consistent. The first place is x, second place is x here, which is the base, and the third place is this x here. All right, this is the three consistent places that we must pay attention to. This t, first, second, third. So these three places must be consistent. In terms of with respect to t, so here we're going to change it to with respect to t. So in terms of definition, right, so all of these will be changed to t. Everywhere x is changed to t. Meaning, no change. Meaning, no change. But if you want to use h, you can use h. No problem. You can use h. All right, we can use h. Oops. Go, I'm going to replace it. Replace this piece. Okay. I'm sorry about that. Okay, so if you want to change it to h, go for it. You can change it to h. Okay, but h delta t, obviously delta t is more expressive as telling us which variables, which variation of the variable is considered. Okay, so now we take a derivative of t. Either you write it this way or that way. But one mistake to be avoided is some people just put an equal sign here. Okay, that would be a terrible mistake because by doing so, you're telling the reader the function and its derivative are the same. That is usually not true. That's usually not true. The only function which is equal to its derivative is e to the power x. Okay, so the only function whose derivative that is equal to, okay, dx e to the power x, whose derivative is e to the power x. And in which case, and there's also these consistencies, x, and e is the special number, okay? It's a special number. So be careful, okay? Don't put an equal sign. Don't put equal sign, throwing an equal sign here and there, okay? Only when you're certain to the left or above the equal sign is the same as the one to the right of equal sign. Okay, so always verify. So these two are the same, so I put equal sign in front of it. And then we're differentiating that, and you can just get 6t squared, right? Minus 6t minus 4. And you're done. You're done. That's really all the work you need to show. All the work you need to show is you copy the question, you find the answer. That's it. You're done. Okay. So let's look at another question, number 9. Over here. Okay, number 9. Maybe I can circle it. Right. So right here, we're doing this question, right? Okay. For number 9, okay, I already copied this question over. So I'm going to just bring it here. All right, so I'm going to find the derivative. Okay, I'm going to find the derivative. And I'm going to put this on the side. And we don't really need it right for now. To find the derivative of this function, d of x, right? We have learned product rule, but in this case, you don't really need a product rule. But you need to, in order to use the power rule without using the product rule, okay? Because product rule adds a little more complexity to it. So unless you have to, I will not use a product rule. Okay, it just keeps life simple. So the derivative of g is equal to, before we take the derivative, I'm going to distribute it. I'm going to take x squared times 1, so that's going to be x squared. And x squared times negative 2x, that's going to be negative 2x raised to power of 3. And then I'm differentiating the latter expanded form. So I'm going to get 2x minus 6x squared. Finished. Done. Finished. Done. All right. 13, I think you can handle it. Let's look at another one. And this one, I think 17, you can handle it. The P is, 19. You should be able to handle the 19, right? Because we did something about the derivative of 1 over cubic root of x, right? So we did that. So you just have to apply the rules to differentiate. Okay. Next one, I'm heading to 23. 23. Okay, 23. So let me circle that. All right, this is the question we're going to work on. And I already copied the question with me. Just cut it and bring it here. All right. And how do I differentiate this function? We know quotient rule, but we don't need to use quotient rule here. You can use a quotient rule, certainly, but we're not going to use a quotient rule here. Okay, but how do I differentiate without using quotient rule? In this case, we can. In some other cases, we can. We may not be able to. So what we will do is that we're going to take the numerator, okay, and we take the denominator to divide into each numerator. Divide into each numerator. Okay. And then we simplified we simplify the function by working the power rule. Oops, sorry. So we're going to simplify it. Okay, so we have learned in our algebra class, right? In our algebra class, these power rules, right? The base to the power of m multiply base to the power of n equals to base to the power of m plus n. Base to the power of m divided by base to the power of n is equal to base to the power of the power on the top subtracting the power in the bottom. So obviously we're going to use these over here. All right. So we're getting x raised to the power 2 minus half, right? Root x is x raised to the power of half plus 4, right? X raised to the power of 1 minus half. Oops, 1 minus half. And the last one, 3 multiply x raised to the power of negative half. Okay? And then, of course, we simplify this 2 minus 1/2, that's 4. That's 4 over 2. 4 over 2 is 2, right? So we get the same denominator, 4 over 2 minus half. So eventually we get the power to be 3/2. And over here, the power 1/2. And we got all the powers simplified. So we got a y equals to that. Okay. And now we can differentiate. We can take a derivative. Do you have to show these? Do you have to show that? You don't. You can go straight here. Okay. You don't have to show these to your readers. You can go straight from here to there. So now we're going to do derivative, dy dx, or you want to write y prime. You don't have to write both. This is either one. Okay. And then we're gonna differentiate according to the power rule. Okay, so where's our power rule? And there, right there, right? So we're gonna apply the power rule. I believe by this time you probably don't really need the power rule next to you, but it's okay if you need more time to get used to it. Okay, so 1 over 2 plus 4 times the derivative of x raised to the power half is 1/2, right? You know what I would like to do? We can just do this, right? The derivative square root of x is 1 over 2 times square root of x. And last but not least, we have 3 multiply, and there's a power is negative half, right? It's a negative half. Make sure you put a parentheses around it. And x raised to the power of negative half minus 1. Okay? Simplify. Okay, simplify. Put it this way, right? So this part is done. And that part is just 2 go into 4, and that's going to be 2. Right? This 2 is gone. Okay? And this part is negative 3/2. Negative 3/2. And x raised to the power of negative 3/2. Negative 3/2. There's some inconsistency here. Sometimes we want to get rid of it, right? Because we have some power expression, we have some root expression. We like to be consistent. We like to be consistent. Either you write all in power or you write all in root. Okay? In this case, I think the easiest part to change is probably just 2 times x raised to the power of negative 1/2. There's a negative 1/2 there. Okay, so that will be consistent. Further reduction. I think we're gonna stop here. Okay, for further deduction, which we need for chapter 4, we will deal with it when we get there. Okay, just so you know, when we get to this form in dealing with more complex questions, then sometimes we need to do a little bit more, such as factoring and so on and so forth. But right now, we don't need to. Right now, we just learn to apply a power rule. Okay? Keep going. Keep going. Let's see what else question we're going to have. 30. I think you guys got these other ones, right? Maybe 25. 25, you have x raised to the power 2.4 e to the power. Let me circle that. Okay, let me circle that. 25. Okay, I'm just going to talk about it, not writing it down. X to raise to the power 2.4, you apply the power rule. But e to the power of 2.4, that's a constant. The derivative of constant is 0. Okay, 29, you should be able to handle. 31, 32. 31, 32. I'm going to do 32. I would do 32. Okay, so I'm going to do 32 to show you, because if in case like you like to work on this question and bewildered by e to the power x plus 1, we have not learned chain rule yet. So what do we do with it? Okay, how do we differentiate? So y equals to, did I copy that question? Oh, I did not. Yeah, I did not. Okay. So the next question is 32. So y equals to e to the power of x plus 1 plus 1. Okay, derivative. Apparently, power rule does not apply here, right? Because power rule is the base is a variable and with respect to the x, with respect to the base. And we have an e, right? So it's more like the derivative e to the power x. We know it is e to the power x, right? But now it's the derivative e to the power x plus 1. What do we do with it, right? So if it changed to e to the power x plus 1, what will be the derivative, right? That's our question. So this is how we're going to work it. E to the power x, right, is e to the power of x. E to the power x plus 1 is e to the power x multiply e plus 1. Okay, so we can put the e in front of it as a constant. Well, that's a constant. So now the derivative of e to the power x plus 1 is just going to be e. Constant doesn't change, right? We have that. right? We have learned that law of limit, right? Constant, just bring it out right here, right? Right there, right? So we get to apply that limit. The derivative of e to the power x is e to the power x and plus 0. So in the end, we get e to the power of x plus 1. E to the power x plus 1. We're done. We're done. After we learn chain rule and you come back to look at this question, you say, oh, okay, done that. And there are two ways to do it. So there's the other way. The other way to do it is to use chain rule. Of course, you're going to get the same, we draw the same conclusion, but a slightly different procedure, slightly different procedure. So let's keep going. Let's keep going. The next section, okay, I copied these questions, but I don't think we're gonna do it. I think I'm gonna leave it for you, unless you have questions, and just reach out to me, and we can work on that. So I'm gonna make another video to work on the tangent line and the normal line. Well, thank you for watching.